Hello and welcome everybody to Toby's Tech Bytes, your regular .NET tech snack, your place for the front end, the back end, and everything. While we covered front end topics the last 3 episodes, we will turn to something completely different now, and this is, how can it be any different? Of course, AI. Everybody's talking about AI nowadays, and so do we. And the thing is, if you want to get started with developing with AI, you might face hurdles like, okay, I need a cloud subscription, I need to pass some compliance stuff, and I don't have all this. I just want to start experimenting real quickly. And so today's topic is really on how you can get started with developing with a language model in just 5 minutes. Yes, you heard completely right. It's just 5 minutes to get you started, to get you up and running with your first AI project running completely locally on your machine. So absolutely no cloud or whatsoever required. Your data remains on your device and you're good to go to experiment with the hot stuff. And the thing that we actually need to make this happen is called Ollama. And this is something that we have to install on our machine, of course. And I like to use winget to install most of the stuff onto my machine, so you can just run winget.install ollama.ollama. Obviously, I already did that. Once this is installed, and you can install it obviously for Mac and Linux as well, you can just use the CLI of it, which you can reach by just typing Ollama. And what you have to do first, you have to pull a model you want to work with. If you visit ollama.com, the website, you can browse all the models available. There are plenty of them, and most of them have a lot of different tags for different parameters, which changes the download size enormously. So just for a very small quick start, we are going to start with the DeepSeek R1 1.5 billion model. This is actually really a small language model, not a large language model, but it's impressively well performing. So in order to just grab the model onto our local machine, we have to pull it, much like a Docker image. We have to say ollama.pull DeepSeek R1 with the tag 1.5 billion parameters. And as you can see, I obviously already pulled the model in advance, and it's about 1.1 gigabyte large, which is pretty small for a language model, so it's still very handy to work with. Now we can use Ollama list, and we can see that we have this model pulled on our machine, and we can run it using Ollama run. And yeah, we immediately kind of see a prompt, and we can ask it something like, what is Java? Something very uncommon on this channel here. And you can see that it immediately starts thinking, because DeepSeek is a thinking model, so it already shows you its reasoning process, and then you get a lengthy response of what Java actually is or might be. And on a different shell, you can say, okay, ollama.ps, and it's going to show you the running models. And with ollama stop, and then with the name of the model, which is actually DeepSeek with the tag, you can stop it. And yeah, then of course we gotta stop it here as well. And another Ollama PS will show nothing. So this is actually a way to run a language model or several other models that are supported by Ollama locally on your machine. But of course, as we are developers, we want to communicate with this model through our source code and not just through a CLI, of course. And for this, there are plenty of options or several options available. The one I'm going to show you is using Microsoft.Extensions.AI, which is kind of an abstraction layer above accessing the, or it's a way of accessing the Ollama API by abstracting away all the lower level details. Another option would be Ollama Sharp, which is a little bit closer to Ollama itself. Or of course, you can just communicate with Ollama through the built-in HTTP API, but this is kind of very low level. So we want to have it as easy as possible. So we're just using some NuGet packages here. What we need is Microsoft Extensions AI, and then Microsoft Extensions AI for Ollama, and then Microsoft Extensions Hosting, because this Extensions AI stuff allows us to integrate classes for handling AI models into a generic .NET host or web.NET host or whatsoever host you are using for your application. You can see as well, I have created 3 example inputs for our model, because what we want to achieve is we want to classify text, we want to summarize them, we want to assign them to a category, and we want the model to assign text to it so that we can kind of like, yeah, get summarized information about given input texts. And I've chosen 3 texts from 3 different categories: fictional text, technical text, and a news text. And let's see how the model is going to perform on that. Okay, so for starters, we need a few using statements, and then we have to create us a host builder, like builder.host.create application builder. And then we gonna use the AI extensions by saying, okay, to this builder, we want to add chat client services, and we use the Ollama chat client, in this case, pointing to localhost 11434, which is the locally running Ollama server. And we want to use the model DeepSeek R1 with the 1.5 billion parameters. And then, of course, we just have to say, okay, we want to build the application from our builder, and then we can just start to use the services registered by grabbing a chat client from the app, and we say, okay, give me a required service of iChat client. And this is the neat thing that these AI extensions are giving us. They are giving us a consistent interface on top of probably several different models. And then we have to write a prompt, and this is basically the hard part of all the AI things you're going to do, because writing a proper prompt is really a difficult thing. For now, let's say we just use something very simple. You can define a prompt as a simple string, or for some more advanced scenarios already, you need something that is called a chat message, and the chat message is given a chat role. So there are different roles you can assign to a message. It can be the system message, it can be an assistant or tool message, or a user message. And the classical prompt that you would present to your language model is a user prompt. So we're just saying, okay, what is Java, as a very simple prompt, because we just want to see quickly how things work with accessing our model via C#. And as you can see, the Copilot is already eager to help us here, but sadly he's doing it wrong. What we need is either get response async. That would mean that in the background the response would be generated, but we won't be able to see anything until it's complete, and then we'll get the whole answer in one shot. But due to the fact that generating the answer can take some time, and if you're an impatient type like I am, you probably want to see the progress of things. So we use get streaming response async here. And this allows us to use an asynchronous for each by just saying, okay, await for each, and then var item in chat_client.getStreaming response async, passing our prompt. And what we get back here is a chat response update, and each chat response update does have a text chunk, and we just console.writeLine then, and we're going to see them onto our console. And this should already be a fully working example. So we can just start this and watch our debug console carefully once things are running. So here it goes. So in the background, it started the Ollama model again automatically. And yeah, we can see, okay, not much to think in this case. Yeah, but again, we get kind of a answer from the model locally, and this time the answer was coming from our C# program. And this is actually all it takes to get started with AI development on your local machine, because everything is running locally on my machine. But we want to cover the scenario of the text classification anyway to have a little more advanced scenario. And what we have to change in order to achieve just this is really only changing the prompt. So the whole structure of the program is staying completely the same. What we are going to do is we are going to use a raw verbatim string to give our prompt to the chat message. And because we will embed source code into it, we need to use string interpolations as well. But as our prompt will contain curly braces as well, we need to double interpolate the string so that our string will recognize curly braces as part of the text, whilst as soon as we want to use string interpolation, we have to use double curly braces. And now we can kind of like access things from our program here. Okay, so that's why we have these double dollar signs in front of our string. Okay, so we will try the following prompt. We say you will be given a text and an output format. You summarize a given text with a maximum of 100 words, find text to classify it, and assign it to one of the following categories: fictional, news, technical, and scientific. The output format: give your answer in the following format in RFC blah 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 compliant JSON. No deviation from this format is allowed. Do not use more than 3 tags. Do not use other categories than the ones supplied. So we try to restrict the model to giving us an answer that we can process technically. And then we supply an example of the JSON structure that we wish to see. It should have a summary field with summary. It should have a text array, and it should have a category field that is holding one of the categories we defined above. So this is kind of an enum to our processing code. So we want the model not to deviate from these 4 given categories. So this is the prompt, and yeah, it should tell the model what to do. And of course, then we have to include the input text. So we're going to add this to the prompt as well by just reading from one of the given input texts. And as always, the code is on my GitHub, so you can read the texts yourself if you're interested. The news text is taken from MSN. So yeah, it's really a news text. So let's see if the model is going to determine this correctly. Okay, all All right, now he's starting to think really hard about it. And in the end, he gives us the JSON response. The text discusses political issues, post-Bundestag elections highlighting voter conflicts and party struggles. It's political and news, and it used political as a category. So as you can see, our prompt seems to be not precise enough. This is why I said crafting a proper prompt is really hard work. And the funny thing is, I tried this out several times before, and it always just uses one of these 4 categories, and everything worked fine. And chances are, if we just start this again, now we're going to see the category correctly assigned. It's news, as it is on the list. The summary is different and the texts are different. This is due to the temperature the model operates with that makes the model kind of like creative in generating the answer. So the same prompt on the same input won't give you the same result in general. So I hope this will help you get started with AI development and gives you fantastic ideas what you can do in your next project and how you can enhance it with AI. So I hope you liked it, and I hope to see you again next time on Toby's Tech Bytes. Bye bye.